Hello everybody, so today we are going to be going over 2.5 vectors. So these are vector addition notes, and let's just jump right into it. So when we are combining vectors, so we are trying to find the resolve or the result of all the vectors. Okay, so when we're combining all of the vectors, accounting for their magnitude and their direction, when we combine them, we are finding their result. Okay, so it's really easy when it's in parallel. And you might have seen this when we were doing the sum of the forces worksheet, right? So those forces were all in parallel. We found the forces in the x and we found the forces in the y. And if they were opposite, then we subtracted. If they were in the same direction, then we added. So that's how easy it was with parallel vectors. Okay, so when they're acting in the same direction, we can add them together. If they are acting in opposite directions, then we subtract them. So, like an example here with Nelly. So Nelly is not moving. So we know that the sum of the forces is equal to 0. All right, so Nelly here is 300 newtons. So we see that her weight, that force is acting down. And then we have a tension force that is acting up. Okay, they are the same magnitude, but opposite directions. All right, so let's just say that we split up the rope into two. So Nellie's weight stays the same. So weight is acting downward in 300 newtons, but now we have to separate it into two ropes for the tension force. So in order to do that, we just divide it by 2, and we say that each rope is supporting a tension force of 150 newtons upward. So her weight is still being supported, and the sum of the forces, or all of the forces added up together, no matter which direction, is equal to 0. Okay. But, and this is a big but, right? But if the vectors are at angles, all right, so let's say that they're perpendicular, there are several options that we can use. Okay, so one of the options, and I would probably choose this option, is the parallelogram rule. Okay, so to find the resultant of two non-parallel vectors, so what that means is that they're not like lined up with each other. Okay, so whether up or sideways. Okay, when they're not lined up or when they're not in parallel, we have to construct a parallelogram wherein the two vectors are adjacent sides. All right, so the diagonal of that parallelogram shows the resultant. And again, the resultant is just the two vectors or how many vectors added together, that combination. Okay, that would be that resultant there. So we have to use the parallelogram rule when our forces are not parallel to each other. Okay, so more when they're perpendicular, so like crossing, all right, at right angles. Okay, and we're going to see an example of this in just a second. So let's move over to the other slide. So we have two force vectors. One is acting north and the other one is acting east. So what would I need to do in order to find out the resultant here? Well, I would construct a parallelogram. So I would show that my x vector up top here, so these are summative, they are equal to each other. And the north one vector is shown just like that. So now we've constructed a nice rectangle or a parallelogram. So now we need to put in our resultant. And our resultant starts at that origin point and works its way out until it reaches that other side in that corner there. Okay, so we just match that side and that is our resultant. It's just like if you were pulling two strings, right? If we had a ball in the middle and we were pulling two strings, that ball would start to travel in a diagonal direction. That is exactly what we are showing here with this resultant. All right, so let's look at some examples here with using the parallelogram rule. So we have a 10 Newton force acting north and an object on an object and 15 Newton force acting east. So let's go ahead and draw out these forces. So we start with our object right there, and we have a 10 Newton force acting north and a 15 Newton force acting east. So I'll just draw in 10 newtons here, 15 newtons to the east. And so now I see that my forces, they're not in parallel, right? They're actually perpendicular to one another. So what do I have to do? Well, I have to draw in a parallelogram. So let's go ahead and do that. So I draw in that parallelogram, and then I say, well, to find my resultant, I just need to go from that origin to that opposite corner, And that would be my resultant here. And now you get excited because you have two triangles and we love to work with triangles. So let's draw these triangles. So we have a triangle here. And our base is equal to 15 newtons. And because we drew that rectangle, we know that the long side is equal to the long side, and that short side is also equal to that short side. So I know that this side right here is 10 newtons. Okay, so this would be my hypotenuse, or R. All right, so now in order to solve, we have to use the Pythagorean Theorem, which says that a squared plus b squared is equal to c squared. But we are not asked to solve for c squared. We are asked to solve for the hypotenuse, which would be c. So how do we solve for c? Well, we say that c is equal to the square root of a squared plus b squared. So c would always be equal to your hypotenuse, or that longest side on the triangle, and a and b would be those other two sides for that triangle. Okay, so c is equal to r, in this case for our hypotenuse, but we'll just put in these numbers here. So it would be 15 squared plus 10 squared. And you just break out that calculator and you solve it out. So we do 15 squared plus 10 squared, and we get 325. So now we have to find the square root of 325, and the square root button is just a button on that calculator. And we get that c is equal to 18.027, or that 18.03. Okay? Sweet. All right, so again, all we had to do was draw out that parallelogram, recognize that we were given two triangles, and then solve for the hypotenuse of that triangle. So C is equal to R in this case. But we are not done yet, right? All we did was find the magnitude. Now we have to give it a direction. So we know that this is north and this is east. So our resultant is moving in the northeast direction. So our resultant is R is equal to 18.03 newtons in the northeast direction. All right, so we are given a second object here, and we know there are 32 newtons acting south on the object and 10 newtons acting west on the object. So let's go ahead and draw out our object. So we start with that little dot, and we draw in those force vectors. So 32 newtons acting, acting south. Let's go ahead and draw that in. It's going to be a very big parallelogram here, but that's okay. 32 newtons, okay? And we have 10 newtons acting west. So that would be this line right here. And again, we recognize that these force vectors are not parallel. They are perpendicular to one another. So we draw in that parallelogram. Just like that. So this side would be equal to 10 newtons, and this side would be equal to 32 newtons. So let me just erase that so people don't get confused here. Okay, so before we even worry about the direction, let's just go ahead and draw in our resultant and solve for that magnitude. So we start at that origin and we go all the way to that corner, which is here. Sorry for my bad straight lines. Go ahead and erase that out. Sorry about this. But we all get the idea, right? You just go and draw in that resultant that way. There we go, that's better. All right, so we call this R. And again, we recognize that we built two triangles, but we only need one triangle in order to solve. So let's just recreate that triangle here. And this side is equal to 32 newtons, and this side is equal to 10 newtons, and this hypotenuse is r, and it's a big question mark to us. So in order to solve for r, we have to use the Pythagorean theorem, and instead of c this time, I'm just going to put in r because it's telling us the exact same thing, but it would be c is equal to the square root of a squared plus b squared. So let's go ahead and put that in. So a squared plus b squared. And so r is equal to 10 squared plus 32 squared. So you just break out that calculator and you say 10 squared plus 32 squared. And you get 1,124. So now you just take the square root of that number and you get 33.53 newtons. And again, we are not finished yet. This only gave us the magnitude. Now we have to find the direction. So we know that this was south and that this was west. So our resultant must be going in the southwest direction. All right, so I hope this was helpful to all of you. Keep working on these examples. Reach out if you have any trouble at all, and good luck on that worksheet.